Okay, so y'all go ahead and do the factoring of the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video, and I'll go over the correct answers. On the factoring, you're going to start off by pulling out your greatest common factor, which is a 4x, and then you're going to have x squared minus 9 left over. And then you can factor x squared minus 9 as x minus 3 times x plus 3. And so that would be the answer for your factoring. For the math knowledge question, they give us a function and they ask for the value of f of negative 10. So to get f of negative 10, we're going to plug in a negative 10 everywhere we have an x. And so negative 10 squared is 100, times 2 is 200. Negative 5 times negative 10 is a 50, and then we have plus 7. So that would give you 257, which would give you D for your answer. All right, moving on to the lesson. We are looking at lesson 96. We're looking at more double angle identities, and then we're going to look at triangle area formula. So hopefully you'll understand more double angle identities and triangle area formula. We want to show that the sine of x plus the cosine of x squared equals 1 plus sine of 2x. So we are going to be using our double angle identities in these show that's. Your double angle identities, I'm going to write over here for you. The sine of 2a equals 2 sine of a cosine of b. The cosine of 2a is the cosine squared a minus the sine squared of a. Or you can write it as 1 minus 2 sine squared a. Or you can write it as 2 cosine squared a minus 1. And then we also have the tangent of 2a, which is 2 tangent of a over 1 minus tangent squared of a. Those are your double angle identities that we're going to be using. We're not necessarily going to use all of them, but those are some of them that we're going to use for these show that's. So we want to show that these are equal. So I'm going to pick the left side to work with. And I'm going to write it down. And so now we're going to distribute. And so if you distribute that, you'll have sine squared of x plus the sine of x times the cosine of x plus the sine of x times the cosine of x again, and then plus the cosine squared of x. Now we can combine those two middle terms to make it 2 sine x cosine x plus cosine squared x. We know that sine squared plus cosine squared is equal to 1. So we have 1 plus 2 sine of x cosine of x. Now if you look at this very first double angle identity here, 2 sine of a cosine of, that should be an a over here. I'm sorry. 2 sine of a cosine of a. That is the same thing as 2 sine of a. And so 2 sine of x cosine of x is going to be the same thing as the sine of 2x, using that double angle identity there. And so that's what they gave you on the right side. And so you got it to equal it. So this would be all of your work. Okay, let's look at another one. Obviously, we're going to want to simplify the left side because you can't really do much with the 1. So we write it down first. And what you're going to want to do is to factor the numerator. And so that's like an x to the 4th minus y to the 4th, which factors as x squared minus y squared, x squared plus y squared. So we're going to have cosine squared minus sine squared, and then cosine squared plus sine squared. And then over cosine of 2x. Well, cosine squared, sine squared, when you add those together, that equals 1. So we really just have cosine squared of x minus the sine squared of x over the cosine of 2x. Now, you can either substitute the numerator or the denominator. The cosine of 2x equals cosine squared x minus sine squared x from your double angle identities. So you can replace either one with the other. I'm going to replace the numerator with cosine of 2x. But you could replace the denominator with cosine squared minus sine squared. But either way, they're going to reduce to a 1. And so that would be your answer because that's what they give you on the right side. And so all of this would be your work. Okay? So that's how you deal with the double angle identities. You do need to be familiar with those so that you can do these without a lot of trouble. We are going to look at triangle area formulas now. And so we have learned the area of a triangle is 1/2 the base times the height. But we can also do it if, we can do it another way if we have a different kind of triangle where we can't easily find the base and the height, or it's not a right triangle or something like that. So they've given you these 3 pictures in the book, and I'm going to show you how to find the area using each of these, and it's going to get you to an area formula that you can use. So if you look here, Z is A times the sine of B. We're going to look at this triangle right here. If we use this angle here, the sine of B would be Z over A. And so you can multiply by A to get this right here. Z equals A times the sine of B. Okay? And so if we use Z as our height here, and we let C be our base, 1/2 the base C times the height A sine of B, which I can write as 1/2 AC and the sine of B. Okay? Now for this one, it's the same triangle, but they drew the base to a different side. And so we're going to use this triangle here. And if I use my angle C, the sine of angle C would be Y over B, opposite over your hypotenuse. So multiply by B, and you have Y equals B sine of C. And so the area, 1/2, well, this A side is the base, and then your height was B sine of C, which gets you to 1/2 AB sine of angle C. We're going to do one more. They draw the height as X. So we're going to use this triangle over here. The sine of angle A is X over C. Multiply by C, and you get that X equals the sine, C sine of A. And so your area is going to be 1/2. Your base here is a B, and then we have times the height, which is C sine of A. 1/2 BC sine of A. And so the formula is going to be 1/2, pick 2 sides, doesn't matter, and then the sine of the angle that is in between those 2 sides. So I'm going to erase my drawings on my pictures, and I'm going to show you that again with the triangle. So 1/2 A and C, A times C, and then the sine of the angle in between them. Looking at the other one, 1/2 A times B, those are your 2 sides, and the sine of angle C, because that's which angle is included in those 2 sides. Looking at the last one, 1/2 B times C, and then times the sine of angle A. So that would be the formula there. Now let's apply it to a right triangle. The area of that is going to be 1/2 4 times 8, which is what we've been doing. The sine of 90, because the angle that's in between them is 90 degrees. What is the sine of 90? This equals a 1. And so that's why your area formula for a right triangle has always just been 1/2 base times height. And the sine of 90 disappears, so you don't really need it because it's just a 1. But this formula would be for non-right triangles. You can do it for any triangle. So they don't give an example in the book. But let's go over one just for practice. So they give us two angles and two sides. We can find this third angle here. We could find the third side using law of sines or cosines, but it'd be easier to find this angle. And it's going to be 70 degrees because 180 minus the 50 minus the 60 gives you 70. And so you're going to do 1/2 the 5 times the 8 and times sine of 70 because that's the angle that is in between our two sides. So 1/2 of 5 times 8 times the sine of 70 would give you like 18.79 approximately. And so that would be how you would work those. Okay, so hopefully that makes a little bit of sense on how you would use your triangle area formula. On your homework, you do get to omit number 19 and 20. So make sure that you do the rest of those tonight so that we can go over any questions that you have tomorrow.